Dialing with potentiometers. Variable resistors, more commonly known as potentiometers, or in electronic slangs as pots, lets you dial in a resistance. The upward value of the potentiometer determines the actual range of resistance. Most potentiometers are marked with this upward value. We have 10K, 50K, 100K, and 1M, and so forth. For example, with a 50K potentiometer, you can dial in any resistance from 0 to 50,000 ohms. Now bear in mind that the range of potentiometer is approximate only if the potentiometer lacks markings. You need to use a multimeter to figure out the component value. Virtually all potentiometers are dial type. You sometimes use the other type, the slide potentiometer, on gadgets like stereo equipment. The dial kind is typically easier to mount into your own projects. With the dial type of potentiometer, you can rotate the dial nearly 360 degrees, depending on the specific qualities of the potentiometer that you're using. At one extreme, the potentiometer has zero resistance. Going through it, at the other extreme, the resistance is the maximum value of the component. Your television volume control or electric blanket control are typical examples of the dial pot. Capacitors, reservoir for electricity. After resistors, capacitors are the second most common component in the average electronic device. Capacitors are interestingly little gadgets. They store electrons by attracting them to a positive voltage. When the voltage is reduced or removed, the electrons move off. When a capacitor removes or adds electrons to the circuit in this fashion, it can work to smooth out voltage fluctuations. In some cases, you can use capacitors combined with resistors as timers. Capacitors make possible all kinds of circuits such as amplifiers and thousands of others. Capacitors are used for all sorts of neat applications, including creating timers, which is a kind of electronic metronome. A timer most often pairs with a resistor to control the speed of the tick, tick, tick. Then we also have smoothing out voltage. Power supplies that convert AC current to DC often use capacitors to help smooth out the voltage so that the voltage stays at a nice constant level. Then blocking DC current. When connected in line in series with a signal source such as a microphone, capacitors block DC current but pass AC current. Most kinds of amplifiers use this function. Then lastly, adjusting frequency. You use capacitors to make simple filters that reject AC signals above or below some desired frequency. By adjusting the value of the capacitor, it's possible for you to change the cutoff frequencies of the filter. A quick look inside a capacitor. Though they may sound many complicated because of all the things that you can use them for, capacitors are really very simple devices. The typical capacitor has two metal plates inside it. The plates don't touch, instead, a dielectric material, which is a fancy term for an insulator, separates the plates. Common dielectrics used in capacitors include plastic, mica, and paper. Farads, big and small. You probably realize by now that just as politicians have an excuse for everything, electronics types have units for measure for absolutely everything. The electronics world rate capacitors by capacitance, expressed in farads. The higher the value, the more electrons the capacitor can store at any one time. The farad is a rather large unit of measurement, so the bulk of capacitor available today come rated in microfarads or a millionth of a farad. You may even came across an even smaller rating, the picofarad, or a millionth of a microfarad. Using the Greek micro character, electronics documentation most often shortens the microfarad. Here are some examples. You can see here, the first one, the capacitor, is the 10 millionth of farad. Then the second one, 1. Capacitor is 1 millionth of farad. Then the last is the 100. Capacitor is 100 million of a millionth of a microfarad.
Audio Jungle.